Okay, hello everybody. This is Julia with my 3003 project. I will start with my first illustration being about similar triangles. Okay, so in this problem, you have these two triangles, triangle ABC and ECD, that are said to be similar, right? Right there. That are said to be similar. And it's asking for you to find the length of side X. Okay, or side CD. Okay, so in this problem, you have three boys, Lee, Chris, and Marty. And they have multiple attacks on how to solve this problem. That is an exemplification of the second part of MP1, which is persevering in solving them. So they exhibit the first part of making sense of the problem by using their prior knowledge and stating that if two triangles are similar, then their sides are proportional and they have a scalar factor. Okay, so the first kind attack that they have is that that Chris says that flip the top triangle down. And this is kind of a misconception and a point that points out they need to be more, that they need to attend to precision, MP6, more clearly, because from saying flip the top triangle down, Chris had one interpretation, but then there becomes a misconception from Marty because he thought that flipping the top triangle down meant flipping it over the horizontal line through C, which doesn't work because the sides don't line up, as Marty says. So then they go on to step number 2, and they try to come at it a different way. In this portion, they reflect it over the line through point C, in which segment AC is a part of the larger segment AE, as represented right here. Okay, so in this, one of the boys notices visually, using the structure of the triangles and how it is mapped out, he notices the structure in P7 that these lines do not look parallel. See, as they, as through my very bad drawing, meet up on the left side of the triangle. And they don't take this at face value, which is attending to precision, but through attending to precision, they use the proportions and through the proportionality of similar triangles, and they find that they are different. And then, okay, and now, which means that in that configuration, they are not similar, meaning that their reflection or was not the correct conception. So this is their third attempt to get it right. And they decided to reflect the image down or over, or they just decide to make another reflection of it. So visually, Marty notices that these lines look parallel, which gives them hope. And through attending to precisions, they look at the proportionality of them, and they find that 1.6 is the scale factor, meaning that this would be a really easy form to move on to. Okay, so our next one is exploration 8.2. In this one, we are looking at quadratics, and we are trying to find the relationship between the leading coefficient and the power of a polynomial and its constant difference. So we start off with something known with the n squared and n cubed, and we find that the constant differences. Oops, this is not a good color. That the constant differences are 2 and 6. And then we went on to find n to the 4, which has a constant difference of 24. And through some experimentation, we found that this equals 3 factorial, 2 factorial, and 4 factorial, and came up with a general representation, which is which exemplifies in P8. To look for and express regularity and repeated reasoning. So because we saw that these all have like a common reasoning, they almost are like a sequence. We came up with the general term that the constant difference of an n to the kth, like polynomial, the constant difference is k factorial. And that is exemplifying how you find regularity. And then in the rest of this uh, exploration, we find we go for higher powers. We go for what happens if you add a second term or if you add a leading coefficient. A leading coefficient. And we find the using the repeated reasoning, we find a new generalized term. And so through attending to precision and making sense of a problem, and MP8, looking for and expressing regularity and repeated reasoning, we were able to find the general form for the second difference of a polynomial of c into the a, or we'll do k, c into the k. The constant difference is c times k factorial. And yeah, that's how we did it. Boom, diggity.